In the vast silence of the cosmos, where stars whisper secrets across light years, we find ourselves drawn to a singular vessel, a silver arrow piercing the veil between worlds. Imagine a ship not born of steel alone, but of dreams forged in the fires of human ambition, carrying the weight of our species' survival. What if this craft, hurtling through the void, held the key to unlocking not just distant shores, but the very essence of what it means to endure? Consider the paradox: a machine designed to conquer the stars, yet vulnerable to the whims of gravity, radiation, and the fragile biology of its passengers. We gaze upon Mars, that rusty sentinel in the night sky, its thin atmosphere a siren call to explorers, promising both peril and possibility. Ancient craters scar its surface like forgotten battlefields, whispering of a world that once cradled water and perhaps life. Now a barren expanse challenging us to rekindle its spark. And in this dance of innovation, where technology bends to the will of necessity, we ponder the upgrades that could transform a mere rocket into a cradle for humanity's next chapter. Nuclear engines that harness the atom's fury for swift voyages, artificial minds that guide landings with unerring precision, and crops engineered to thrive in alien soils under feeble gravity. These are the threads weaving our future tapestry. Yet, as we stand on the precipice, one cannot help but wonder, in reaching for the red planet, are we truly escaping our earthly chains, or merely extending them into the infinite? Picture the grand theater of our solar system, where Earth spins like a blue marble in a sea of darkness, and Mars orbits as a crimson counterpart, separated by an abyss that has taunted humanity for centuries. This is the stage upon which Starship emerges, not as a fleeting spark, but as a colossal beacon of engineered defiance. Towering over 120 meters, its stainless steel hull gleams under the harsh glare of launchpad lights, a monument to reusable ambition born from the minds at SpaceX. We have witnessed its early flights, those thunderous ascents where flames lick the sky and prototypes dance with destiny, sometimes crumpling in fiery embraces with the ground, other times soaring to suborbital heights that tease the edge of space. But the future beckons with promises of evolution, upgrades that propel this vessel beyond its current form, into realms where propulsion systems evolve from chemical fury to nuclear elegance, where landing becomes an autonomous ballet orchestrated by silicon intelligence, and where life support innovations sustain human outposts in the unforgiving low-gravity embrace of Mars. To grasp this trajectory, we must immerse ourselves in the cosmic scale. The journey to Mars spans an average of 225 million kilometers, a void where solar winds howl silently and cosmic rays pierce unprotected flesh like invisible arrows. Starship, in its present iteration, relies on Raptor engines that gulp methane and oxygen, thrusting with the power of 17 million pounds at liftoff, enough to rival the Saturn V that once ferried astronauts to the moon. Yet, as we envision its future, we see a craft refitted for endurance, capable of refueling in orbit like a nomadic bird sipping from celestial oases, enabling round trips that shrink the psychological chasm of isolation. The Martian landscape itself is a character in this saga: vast plains of regolith dusted with iron oxide, polar caps of frozen carbon dioxide that sublime into ghostly mists, and canyons like Valle Marineris, a scar 4 times deeper than the Grand Canyon, stretching as if clawed by some ancient god. Here, gravity pulls with only 38% of Earth's strength, a subtle thief that atrophies muscles and bones over time, demanding innovations in bioengineering to anchor life. We reflect on the emotional weight of such a venture, the awe of standing on alien soil, the reverence for a planet that mirrors our own in its volcanic past, with Olympus Mons rising 21 kilometers high, dwarfing Everest as a testament to geological might. In this expansive reverie, Starship becomes more than machinery. It is a vessel of hope, bridging the intimate scale of human fragility with the indifferent grandeur of the universe, where every upgrade whispers of our collective yearning to not just visit, but to belong among the stars. Beneath the visible spectacle of launches and landings lie the hidden signals that foretell Starship's metamorphosis. Data streams from sensors, telemetry pings echoing through mission control, and simulations that map uncharted futures. These are the unseen pulses, captured not by the naked eye but by arrays of instruments that decode the language of physics. Consider the thrust profiles of nuclear thermal propulsion. In laboratories on Earth, engineers at NASA and private firms test reactors where hydrogen propellant is heated to 2400 Kelvin by fission's controlled rage, expelling exhaust at velocities twice that of chemical rockets, slashing transit times to Mars from months to mere weeks. We detect these advancements in the subtle anomalies of tested firings, where exhaust plumes reveal efficiencies hidden in spectral lines, infrared signatures betraying the heat of atomic hearts. Similarly, AI autonomous landing systems emerge from the digital ether, their algorithms trained on vast data sets of wind shear, terrain mapping, and gravitational perturbations. Signals gleaned from LiDAR beams bouncing off simulated Martian dunes, or radar echoes from real-world analogs in Earth's deserts. These systems process inputs at speeds beyond human cognition, adjusting thrusters in milliseconds to counter the chaos of entry, descent, and landing, where atmospheric density varies like a fickle breath. And in the realm of bioengineered crops, we uncover genetic markers in laboratory trials. CRISPR-edited plants that express proteins resilient to low gravity, their roots delving deeper into hydroponic matrices, leaves photosynthesizing under LED spectra, mimicking Martian sunlight. These are not mere inventions, but responses to detected imperatives. The radiation flux measured by Mars rovers like Perseverance, the soil toxicity analyzed in return samples, all weaving a tapestry of evidence that demands evolution. Through telescopes and probes, we intercept these cosmic missives, transforming raw data into blueprints for survival, each anomaly a clue in the grand puzzle of interstellar migration. In this shared odyssey, we feel the pull of connection, as if the stars themselves invite us to reflect on our place within them. The innovations ahead stir a warmth in the soul, reminding us that every leap into the unknown binds us closer, turning solitary dreams into a collective heartbeat of wonder. Let us journey back to the Genesis, to the primordial forge where Starship's lineage began, not in the clean rooms of today, but in the chaotic birth of rocketry amid the ashes of World War II, evolving through the Cold War's fevered rivalries into the reusable marvel we know. Envision the early days, Robert Goddard's liquid-fueled rockets sputtering in New Mexico fields, their flames a nascent cry against gravity's tyranny, paving the way for von Braun's V-2s that scarred Europe yet pointed humanity skyward. From this elemental dust arose the Saturn V, a behemoth that hurled Apollo crews to lunar triumphs, its chemical propulsion a brute force echoing the Big Bang's own explosive origins. But Starship's story delves deeper into the chemical alchemy of methane and oxygen, chosen for their abundance on Mars, allowing in situ refueling like ancient nomads drawing water from desert wells. We trace this back to the solar system's formation 4.6 billion years ago, when a collapsing nebula birthed our worlds from swirling gas and dust, elements like carbon and iron coalescing into planets that now fuel our ambitions. Philosophically, this mirrors the slow emergence of order from chaos. Just as protoplanetary disks accreted into stable orbits, so too does Starship's design iterate from Falcon 9's reusable stages, each failure a collapse birthing refinement. Extend this to nuclear thermal propulsion's roots in the 1950s Project Rover, where fission reactors were envisioned for interplanetary travel, their uranium cores splitting atoms in a controlled mimicry of stellar fusion, promising specific impulses of 900 seconds versus chemical rockets' 450. Delve into case studies. The Nerva engine, tested in Nevada's Jackass Flats, where exhaust plumes scorch the Earth, revealing efficiencies that could have Mars transit times, reducing cosmic radiation exposure from 1,000 millisieverts to half, safeguarding fragile human DNA. Reflect on the poetic rhythm of time, eons compressing into engineering timelines, where AI systems trace their ancestry to Alan Turing's computational dreams, evolving into neural networks that now simulate landings with 99.9% accuracy, as seen in DARPA's autonomous vehicle challenges. And bioengineered crops hark back to the Green Revolution's hybrid wheats, now advanced by gene editing to withstand low gravity's pull, where microgravity experiments on the ISS show plants like Arabidopsis thaliana adapting via altered gene expression, their stems thickening against atrophy much like human bones in space. In this mythic rewind, we see not just technology's birth, but humanity's eternal quest to harness the universe's fire, dust turning to vessels that carry life across the void, a nostalgic echo of our species' first migrations from African savannas to global expanses. Science, in its essence, is the art of unraveling memory etched into the fabric of reality. Ancient light from distant stars, fossilized imprints in rock, or data logs from exploratory missions that preserve the whispers of what came before. For Starship's future, we read these records in the telemetry of past flights, where sensors captured the vibrations of re-entry plasma, informing upgrades that fortify hulls against 1,600 degrees Celsius infernos. Nuclear propulsion secrets lie in archival tests from the 1960s, particle accelerators revealing how neutrons dance in reactor cores, their interactions modeled in supercomputers that simulate fuel rod behaviors over decades. We decode AI landing systems through vast archives of Mars imagery from orbiters like MRO, whose high-resolution cameras map craters down to meter scales, feeding algorithms that predict dust storms' erratic paths. Bioengineering draws from genetic databases, where sequences from extremophile bacteria in Antarctic dry valleys, surviving radiation doses lethal to most life, inform crop modifications for Martian regolith laced with perchlorates. These relics, preserved in digital vaults and peer-reviewed journals, allow us to peer into the past, reconstructing pathways to innovation, much like astronomers trace cosmic microwave background radiation to the universe's infancy. The voices of discovery resonate through the scientific chorus, from Elon Musk's visionary proclamations at SpaceX briefings to the meticulous work of NASA engineers on the Artemis program. Consider the Starship prototype's iterative tests at Boca Chica, where SN-15's successful landing in 2021 marked a milestone. It's thought of paving the way for AI enhancements drawing from Boston Dynamics' robotic agility. Nuclear thermal pursuits echo in DARPA's Draco project, announced in 2021, aiming for a 2027 demonstration with companies like General Atomics, crafting reactors that could propel Starship at 20 kilometers per second. Researchers like Dr. Franklin Chang Diaz, with his Vesimar plasma engine concepts, bridge to hybrid systems, while AI advancements stem from collaborations with Google's DeepMind, whose AlphaFold predicts protein structures aiding bioengineered crops. Missions like Perseverance's 2020 landing, with its MOXIE oxygen generator, foreshadow in situ resource utilization, timelines projecting Starship's first uncrewed Mars flight by 2026, crewed by 2029. Beyond the gleaming exteriors, invisible landscapes shape Starship's destiny. Quantum computations in AI cores, subsurface Martian aquifers hinted at by radar data, and the ethereal web of dark matter influencing galactic travels. Nuclear propulsion unveils hidden thermal gradients within reactors, where fission's energy cascades through ceramic matrices, unseen forces multiplying thrust. AI systems navigate probabilistic terrains, their neural layers processing gravitational anomalies that warp trajectories like hidden currents in an ocean. For biocrops, low-gravity environments reveal cellular depths where microtubules in plant cells reorganize, adapting to forces as subtle as Earth's magnetic field. Comparisons to human vestibular systems, evoking shared evolutionary struggles. These unseen realms, from quantum entanglements enabling secure communications to regoliths mineral lattices binding water molecules, evoke suspense in their density, contrasting microscopic intricacies with cosmic scales. Against the Martian void, life asserts itself with tenacious grace, much as microbes in Earth's deepest mines endure crushing pressures. Their metabolism's a blueprint for bioengineered resilience. Envision crops like modified potatoes, genes spliced from tardigrades to withstand radiation and desiccation, thriving in hydroponic domes where low gravity fosters elongated roots that mirror human adaptations in space. bones fortified by resistance exercises. This persistence echoes extremophiles in Yellowstone's scalding springs, surviving temperatures over 80 degrees Celsius, paralleling the hope that humanity too can flourish in hostility through ingenuity. Our gaze widens to refuge worlds like Europa's icy shell, concealing subsurface oceans where hydrothermal vents might nurture chemosynthetic life, or Titan's methane lakes, hydrocarbon havens for potential biospheres. Enceladus spews water plumes rich in organics, shocking facts revealing temperatures warm enough for liquid water beneath, drawing comparisons to Mars's own hidden reservoirs, each a canvas for Starship's extended reach. In this unfolding saga, attention grips us, sharpening our senses to the fragility of our cosmic aspirations, urging a deeper awareness of the choices that define our path among the stars. We bear our own scars, echoes of environmental hubris on Earth, mirroring potential pitfalls on Mars. Deforested lands like the Amazon's shrinking canopy, where biodiversity collapses under human expansion, paralleling overzealous colonization that could contaminate Martian ecosystems with unchecked bioengineering. The unraveling accelerates in visions of unchecked ambition. Starship fleets descending en masse, their landings churning regolith into dust storms that blot out solar panels, systems collapsing under radiation's relentless assault, nuclear reactors overheating in thin atmospheres, AI faltering amid unforeseen anomalies, crops withering as low gravity disrupts vascular flows, a visceral cascade evoking Earth's climate tipping points. Yet hidden stakes lurk in the interplay of motives, corporate drives for resource extraction, clashing with ethical imperatives for sustainable exploration, political rivalries between nations like the US and China, fueling a new space race, economic models projecting trillions in helium-3 mining from lunar outposts, moral dilemmas over genetic modifications raising specters of inequality, historical patterns from colonial eras warning of exploitation, analogies to deep-sea mining debates underscoring the need for balanced progress. Two futures diverge, one of dystopian decay, where Mars becomes a littered graveyard of failed habitats, radiation-scarred colonists succumbing to isolation, bioengineered failures leading to famine. The other, a hopeful renaissance, with nuclear-propelled starships enabling thriving dome cities, AI orchestrating harmonious landings, crops yielding bountiful harvests under artificial suns, personal responsibility tipping the scale towards stewardship. In quiet reflection, we find resonance in these visions, the poetry of human endeavor stirring the soul to embrace the stars with mindful grace. What legacy shall we etch into the cosmos, reframing that initial mystery of a ship defying the void? Our journey, woven into the greater human tapestry, speaks of survival across generations. Lessons from Earth's fragile biosphere informing ethical expansions, where Starship's upgrades ensure not just arrival, but enduring harmony, leaving a light of wisdom for those who follow.